welcome everybody. This is cool to have you on here. This is the first kind of virtual workshop that we're going to start doing here on the Discord server from here on in. This is one of the few different types of events that we're going to start having, so it's great to have you all here. Before we start, let me just get a few kind of bits of housekeeping out of the way. By the way, if you can't hear me clearly or anything, please let me know through the chat, and that would be the best way to communicate with us. So as I said, this is the first of many events that we want to start having on the server. Today we're hosting a virtual workshop, but in the future we're thinking about hosting AMAs, live coding sessions, and we'll also start a book club, as well as continued workshops on an evolving set of topics, always influenced by the community, of course, so always feel free to let us know what you would like to see in the future. But speaking a little bit more precisely about today, in this workshop, we'll have a bit of like an A to Z walkthrough by our CTO, Mohammed, who will show us how to not only build a serverless app that creates a gym plan for us and sends it directly to our phone, but we'll also see the process to deploy it to AWS with GitHub Actions. The resulting code, just so you know, will be available inside the Tailwarden organization on GitHub, and so free for you to use and to play around with. And yeah, what else? In terms of asking questions, please feel free to ask as many questions as you want throughout the session. We only ask that you do it through the chat. I'll be moderating, and if there's anything that I can answer throughout the workshop, I will. But if not, we'll leave the questions to the very end, where Mohammed will reserve some time for him to address any of those questions that come up. Speaking of Mohammed, he is the speaker for our workshop today, and just a little bit of background on him. So he's a software engineer who has a vast experience in the DevOps world, a regular conference speaker, and an author of several books, specifically around serverless and distributed applications. He's also a contributor to numerous open source projects such as Jenkins, Docker, and Telegraph. And most importantly, he is the creator of Commissar and the co-founder of Tailwarden, along with Cyril. So we're definitely in good hands when it comes to serverless deployment and development, and so I know today is going to be good. Lastly, I just to let you know, I'm going to mute the server just so we don't interrupt Mohammed as he goes through the workshop, and just communicate through the chat. Would appreciate if we can do it that way. At the very end, I'm going to share a quick 5-question survey, mainly just with the objective to get an idea of what you would like us to touch on in future workshops. So if you have the time to fill out that survey, I would really appreciate it. And I think that's pretty much everything I wanted to touch on before. I'll have a chat with you once Mohammed is done. But Mohammed, the floor is yours.
Hello, Jake. Thanks for the nice intro. So as Jake explained, we are going to build a service app that will send you a workout plan with like technologies like AWS Lambda, Twilio, ChatGPT, and Golang. So without like a further ado, let's get started. So let me share my screen, and I will walk you through first the architecture, and from there we're gonna start writing some code to build this application. So the first thing I'm gonna cover is the architecture of the app we are going to build. So as you can see here on the screen, the architecture will be divided to multiple like services. So mainly we will have an AWS Lambda function, which will be interacting with ChatGPT, like to get like the workout plan by sending like a prompt. From there, once like the output or the workout plan has been generated by ChatGPT, we are going like to leverage Twilio SDK so that we can send a message and push the message to our WhatsApp account. And to automate this overall like generation of workout plan, I'm gonna like define a cron job through EventBridge rules. That way we can like make sure that we receive this workout plan, for instance, at 7 p.m. every weekday, so that before I go to the gym, I'm sure that my workout plan is ready, and I can like focus on the workouts versus planning like what I'm gonna do at the gym. And also we are going to use AWS Lambda GitHub Actions because we want to automate this overall process of deploying like the Lambda function to AWS, but also like automating the process of improving the workout generator. Because at the end of the demo, which I'm gonna like show you here on this event, this is like just like a basic workout generator. So I would like to see like the different improvements you are gonna like add to this application, and to make sure that those improvements could be done and added like efficiently to our application without like triggering the deployment manually. I'm going to automate this overall process, and as Jake said, all the source code will be shared on the GitHub repository. So for those that cannot attend this meeting, like the video of the event as well, the source code will be uploaded to YouTube later on, so that you can check out and build this application by yourself. So now that we know like the architecture we are going to build, so now we can get started. So the first thing we are going to do is like write our Lambda function, or like the Lambda handler. And for that, we are going to use Golang as a programming language. But again, like all the like the implementation can be like easily converted to any programming language that you are familiar with. But for the sake of simplicity, I'm gonna use Golang for this demo. So here on my editor, I have already created an empty folder. I call it this folder workout generator. So the first thing I need to do is to write the Lambda handler, and for that I'm gonna write a main.go file. So this is where like my main application will be written in. So the first thing I'm gonna do is like to like declare the package. So let me just like increase a little bit like the font size so that everyone can see what I'm writing. So once I declare the package, I will declare the main function. So the first step we need to do, and like again, let's go back to the architecture diagram. We need like to interact with ChatGPT so that we can generate the workout plan. And for that, we need like to leverage the ChatGPT SDK for Golang. So I'm gonna like look to the documentation of ChatGPT and see if they have any official SDK that I can use to interact with ChatGPT. So here I'm on the OpenAI platform. Again, you can create a free account, so I'm not gonna cover how to create an account because there are a lot of resources online that showcase that. But once you have created an account, you need like to go to the documentation section, then the libraries, and from there you will have like the different libraries that are created or supported by OpenAI. So as you can see here, we have the Python library, the Node.js library. But for us, since we are writing our code in Golang, so we need like the library for Golang. So here we have a library that has been like created by the community. So let us check this out and see if it's well maintained. And as you can see, it's well maintained and it has a lot of stars and also a lot of open issues and pull requests. So we can leverage this one for the integration with ChatGPT. So the first thing we need to do is go to the README file and see how we are going to integrate this library. So the first thing we need to install the package. So let me grab this command, and then here on my terminal, I'm gonna like paste the command so that I can download the package. And there I'm gonna like copy this example that showcase how to interact with ChatGPT. So I'm gonna just copy this one, and here on my main function, I will paste it here. And let us go through the code to explain it instruction by instruction. So the first one, or the first instruction, is to create the OpenAI client. And for the clients, it expects a token. So I'm going to show you how you can generate your token from the OpenAI platform. Once this is done, then you you can like initiate a chat with the ChatGPT. So here you can define the model that you want to use. So for this example, I'm going to use like GPT-3, but you can also use GPT-4, for instance, if you want. And of course, you need like to pass the prompt on the content attribute, which is like the question that you want to ask ChatGPT. And finally, we are just going to check if there is an error. There is no error, then we can display the output or the response of ChatGPT. So the first thing I'm going to do is generate the token. So for that, let me go back to the OpenAI platform, and then I should go to my account. And here from the drop-down menu, I have few API keys. And as you can see here, you can generate a key. I have already generated a key in advance. So here I'm gonna like load this key from the environment variable. So I have an environment variable that stores this key, and the name of the environment variable is OpenAI token. So what I'm gonna do for the sake of example to test out if the integration is working, let me ask ChatGPT a question. For instance, I will ask it if AWS pricing is easy to understand. As we know, the AWS pricing is very complicated. So let's see if ChatGPT thinks the same. So now we have like a code snippet for the integration. So what I'm gonna do now is try to run this one and see if ChatGPT integration is working. So for that, I'm gonna run my code by using the go run command. So it says that I cannot say if AWS pricing is easy to understand or not, but some customers might find it easy to understand and navigate, while others might find it challenging. So let's take this as a yes for now. So as you can see, we have been able like to integrate with ChatGPT and pass it like a prompt. And now we can try to tweak this prompt so that we can generate our workout plan. And for the sake of simplicity, I'm not gonna like try those prompts here on the source code. I'm gonna like leverage the ChatGPT dashboard or console. So here I will start a new chat. I will just like use the default model, which is ChatGPT 3, but you can use ChatGPT 4 if you want. And as a simple prompt, I'm gonna ask ChatGPT to generate a workout plan for me. So for instance, on the prompt, I can say, give me like a 45 minutes workout plan. So as you can see here, I have like a simple workout plan, which like takes into consideration the time limit that I have or the time I want to spend on the gym. So as you can see, it's a little bit long, and because we want to send this like to like our WhatsApp or our phone number, we want like to make sure that the message is not truncated, and at the same time, it's really easy for us to follow the plan while being in the gym versus like reading all this text. So what I'm gonna do is I will tweak like the prompt so that I can tell ChatGPT to follow a certain format of the workout plan. So I can of course originate the response, but just for the sake of the demo, I'm just gonna copy this one, paste it here, and I will tell ChatGPT to follow this format. Like I want like the name of the exercise, how many minutes, and then for each exercise, I want ChatGPT to tell me how many reps and how many sets for each exercise. So as you can see now, it's much better. So we can of course keep tweaking this one, for instance, to say that I want just like weightlifting exercises. And let's try this one to keep it brief. So now we have our workout plan. So what I'm gonna do is I'm gonna copy this prompt and go back to my source code and pass it here on the content part. So let us do this, and let me format this one. And now if we run the code, we should have our workout plan. So as you can see now, we have our workout plan. So now we were able to interact with ChatGPT and generate our workout plan. So the next step is send this workout plan to our WhatsApp phone number. And for that, I'm going to use Twilio. So Twilio is like one of like the most famous platforms when it comes to then SMS or sending like text messages or also it interacts with WhatsApp. So it makes it very easy for us to plug and play the platform and leverage it as a way to send those messages to our target channel. For this demo, I'm going to use WhatsApp as my target channel. So I have already created a free account, so it's really easy to create a free account. And once you create a free account, it will give you like $15 as a free plan, which will be more than enough like to cover this demo and also to have your application running for a few months. So once you have created an account, the first step you need to do is like confirm your phone number. So you need like to give it your phone number, and you will receive a code that you need to confirm so that your phone number is valid. That way Twilio can check if the phone number is valid so that it doesn't spam people, and also make sure that their platform is always reliable for their customers. So once this is done, then you can leverage their SDK so that you can send messages either like to your phone number or to like a platform like WhatsApp. So the same way we did for ChatGPT and OpenAI, we need to leverage the SDK for Twilio. So for that, I'm gonna like check if there is a Twilio Golang SDK. As you can see, there is this one, which is created by the Twilio company. So it's the official SDK. So I'm gonna use it for my integration. So again, the first thing we need to do is to install the package or the module. So for that, I'm going to copy this command, go back to the terminal and install the module. And from there, I'm going to check on the README and see if they have an example of how we can interact with Twilio. So on this part, I have an example of how we can send a text message. So I'm going to copy this code snippet. I'm gonna pass it here. So the first thing we need to do is authenticate with Twilio. And to authenticate with Twilio, we need like to pass the username and the password. So I'm gonna copy this one and I will place it here. And since we have already created an OpenAI client that is called client, I'm gonna change the variable name from client to Twilio. And you need to pass to declare the Twilio API here, since I'm using it below to declare the message params. So the first thing we need to do is to pass the username and the password. So the username and the password, according to the documentation, is the account ID and the token. And you can get those informations by going to your dashboard, go to your project. And when you go to the project, you will have the account ID and the token. So those credentials, I have already declared them as environment variables. So for that, I'm gonna just load them from here as environment variable. So I have an environment variable called Twilio username, which holds the account ID, and I have another one called Twilio password, which holds the token. Now what we need to do is like to pass the phone number that you're gonna send our workout plan to, and also the phone number that you're gonna send the workout plan from. For the from number, it's a number that Twilio will give you during the integration. So once you create an account, it will generate a number for you, and this is the number that you will be using on the from attribute. As well, for the to number, it's your phone number that you need to confirm during the registration process of Twilio. So I'm gonna like add some links afterward on the README of the project with how you can create an account of Twilio and how you can confirm your phone number. But for the sake of this demo, I'm gonna just like skip those steps so that we can focus on building the app versus the registration process. But overall, the registration process is very like efficient and really smooth, so it shouldn't be an issue. So again, here to pass the phone number, I'm gonna use like an environment variable which holds my my phone number, and another environment variable that holds my from number that Twilio has generated for me. So for that, I'm gonna use this format. So this is the format that Twilio is expecting if we want to send our message to WhatsApp. So we need like to use the WhatsApp prefix, use double dots, and here we need to pass the phone number. And the phone number, I'm going to load it from an environment variable. So I'm going to copy this one, and I will do the same here. And instead of using the true number, I'm going to use the from number environment variable. And for the body, I'm not going to send this default message. I want to send the workout plan that ChatGPT has generated for me. So I'm going to use this variable, which holds the response of ChatGPT. Finally, I'm just going to like do some changes here. So the first thing is I'm going to just check if there is an error. And if there is an error, I will just print it. If not, I'm gonna just print a message saying that workout plan has been sent. So let's go through the source code once again before building it. So the first step is to create an OpenAI client, create a chat with ChatGPT. We give it this prompt to generate our workout plan or our 45-minute workout plan by using this following format. From there, we initialize the Twilio clients, and then we create the message by passing the true number and the from number, as well the response of ChatGPT. And if everything is successful, we print this message. So let's try to run this one. So again, I will use the go run command, and hopefully it will generate the workout plan and send us a WhatsApp message with the workout plan. So it will take a few seconds. So as you can see, my workout plan has been generated. Of course, it's a little bit long, but again, we can always tweak the prompts, so to specify the number of exercises we want on our plan, or the type of exercises. But I think you got the idea, so you can tweak the prompts afterward. So let's see if we have received the WhatsApp message. So as you can see here, I have received my WhatsApp message, and it's a little bit long, so that's why it was truncated. So now we have like a simple application that generates our workout plan and send it over to our WhatsApp by using Twilio. So what we're gonna do next is deploy this application to AWS, and for that we are gonna use AWS Lambda as a service. So what I need to do is to convert this source code to an AWS Lambda handler, and for that I need to declare a handler for my function. And then I will copy all this source code. I will paste it here. And for the handler, I want it to return an error if there's an error. So here I need to tweak a little bit the source code to return an error when there is an error. And finally, if it's successful, I will pass a nil value. And to register this as a handler for our function, we need like to define it as an entry point. So I'm going to use the Lambda Go SDK and register the handler as an entry point. So now we have our Lambda function. So what I'm going to do is make sure that we have all the packages. So what we're going to do now is try to deploy to AWS Lambda. But for this demo, I'm not going to do this deployment manually. I'm going to use AWS SAM, which is serverless application model that allows us to define our serverless architecture through YAML files, and then it creates CloudFormation stack for us. So this is what I'm going to do. So for that, I need to create a template.yaml file. And on this template, I need to define the Lambda function attribute in terms of like the memory, the timeout, the environment variables, etc., etc. So I have already created a template in advance because I don't waste time on that. So I'm just gonna copy it and paste it here, and I will explain what this template is about. So here on the resources section, we have defined one resource, and this resource is a Lambda function. So the name of the Lambda function will be workout generator. It uses the main as a handler, and it's using Go as a runtime because we have written our function in Golang. On the timeout, I have increased the timeout because by default it's 5 seconds. So I have increased it to 20 seconds because sometimes ChatGPT can take some time to respond. And finally, I have passed my environment variables that I am using on my source code. So those are the different environment variables. And for the values, I have defined the values on the parameter store. So here on my AWS console, I have used the system manager service, and on the parameter store section, I have like defined the values for my environment variables. But again, if you are going to use this in production, I recommend to encrypt those values or use a secret manager for that. But for the sake of this example, I have used system parameters. So now I have my template file. So what I'm gonna do first is try to create my deployment package that will hold the binary of the Lambda function, and for that I'm gonna use the SAM build command. So as you can see, it built my deployment package, and finally I'm gonna deploy my Lambda function. So I'm gonna use the SAM deploy command. I need to fill certain values, like for instance the stack name. So for the stack name, I'm just gonna give it the same name as my function, which is workout generator. I would use the default region, and I will leave everything by default. So as you can see, now it's going to create my CloudFormation stack, and it will deploy or create a Lambda function called workout generator. As you can see, it's going to create two resources, an IAM role for my Lambda function, and then the Lambda function. So it's going to take a few seconds for the stack to be created. So our IAM role has been created. Now it's creating the Lambda function. So the Lambda function has been created, and our stack has been successfully deployed. So let's check if the Lambda function has been created on our AWS account. So I'm going to go to the Lambda dashboard. I'm going to check the latest function that has been modified. And as you can see, we have our workout generator that has been created. So let's test if this Lambda function is working. So again, I'm going to use this test event. So I'm going to give it as a name, a demo. And for the payload, I'm going to pass up empty payload because like our Lambda function doesn't expect anything as an input. As you can see here, the handler doesn't expect any input. So for that, I'm going to use an empty payload. So I'm going to just save this event so that I can use it afterward. And then I will click on test. And now it will interact with ChatGPT, generate the workout plan, and then send the workout plan to my WhatsApp account. So as you can see here, this is the workout plan, and the workout plan has been sent. And again, if I open my WhatsApp web app, as you can see, I have received my workout plan. So now what we're gonna do is, instead of triggering this Lambda function manually, because this is like not productive, because we wanna make sure that our workout plan will be generated for us automatically and idly before we hit the gym. And for that, we are going to leverage EventBridge rules, which allow us to create some kind of cron jobs by using cron expressions to like define like the specific time that we want to like trigger a specific service. And on this example, we want to trigger, for instance, the workout generator, let's say each weekday from Monday to Friday at 7 p.m. because this is the time I go to the gym. So again, to do so, we need like to do these changes from AWS Lambda. So we need like to update the template so that we define this event. So I have already this code snippet created in advance. So I'm just gonna copy it and paste it here. So here I have added this event, which would be a scheduling event. And here, this is the cron job that I have defined it. So this basically will just trigger my Lambda function like on the weekdays. So from Monday to Friday at 7 p.m. So now we have added this cron job. Let's deploy it to our AWS account. So for that, we need to run some build again and run some deploy. I will leave everything by default this time. And now it will deploy those new changes to our AWS account. So as you can see, it will create an event, and then it will create an additional permission so that events can trigger our Lambda function. So again, we give it a few seconds to run. And normally, if afterward we refresh this page, we should have a new trigger, and this trigger will be the event that will trigger the Lambda function at this specific schedule. It's still creating the resources. So the event was created, permission has been created. And now the stack has been updated. So now if we refresh this page, we should have our events. And if we click on it, we'll see that this event will be triggered at this specific schedule. So now it's working fine. So what we're gonna do next is try to like automate the deployment process, because we're gonna like change the prompts based on our like age, gender, and our like one PR max, so that we have like a personalized workout plan. And to avoid building and running those commands manually every time on my terminal, I'm gonna like push this source code to a GitHub repository and then like leverage GitHub Actions so that I can create some kind of a CI/CD pipeline for my application. So for that, the first thing we need to do is have a GitHub repository. So I have here a GitHub repository that I have already created, which is for now empty. So what I'm gonna do is like push this source code to our GitHub repository. So I'm gonna just like copy the clone link, and here I will initialize this folder to be GitHub repository. Then I will add the origin of the repository. Then I will just create a git ignore file because I don't want to push like the AWS SAM folder. And now we should be good to push those changes to our repository. So we'll push it to the master branch. And of course, in reality, you need like to use a proper branching model. For this example, I'm just going to use the master branch. So now if I refresh, I have my source code. Now we will take it a little bit further and introduce GitHub Actions so that all the commands I have been running locally on my terminal, I will let GitHub Actions do that for me every time. Like I'm pushing something to my master branch. That way my application would be every time updated, and I will make sure to receive like the proper workout plan before I hit the gym. So for that, I will need to create a GitHub folder. Within the folder, I need to create workflows folder, and within that folder, I will create a release.yaml file, and this is where I will define like the different steps of my CI/CD pipeline. Again, I have created already the template file, so not waste time. So let me just go through it. So this pipeline will be triggered only if we are pushing or changing something on the master branch. And if it's the case, then this is the following steps of my CI/CD pipeline. So the first thing will be cloning the source code, or like getting the latest changes, setting up the Python environment because this is something needed for SAM and AWS CLI. And then we will like set up SAM or like the CLI that we can like use some commands afterward. Then we need like to configure the AWS credentials because we are going to deploy changes to our AWS account, so some need to have those proper permissions. And finally, we run the SAM build command and the SAM deploy command. The only thing that has changed compared to what I have been running locally is that I'm passing those flags so that SAM won't be on an interactive mode, so that it will be run within the CI/CD pipeline. As for the different credentials, I have already added them in the beginning as a secrets on my GitHub repository, as you can see here. So now we have a working pipeline. So let's test it out. So I'm gonna push those changes again to our master branch. So I'm just gonna add a proper commit message and then push this to the master branch. So now if we refresh, we should have our pipeline. Now if I open the actions, as you can see, I have my CI/CD pipeline. So it was triggered twice because I pushed everything on the master branch for the first time, but it shouldn't be the case for future commits. So let's see, for instance, this build and see if the pipeline will be successful. So as you can see now, it's installing the SAM CLI. So SAM has been installed successfully. So now it will be configuring the credentials from the secrets, and then it will run the SAM build command like to generate the deployment package for our Lambda function. So as you can see here, I have my deploy command that is running, so it will like update the CloudFormation stack and update the changes to our AWS account. So here we have an issue. Right. See what this issue is about. Okay, let me. Okay, I think because it was running at the same time, so that's why we had this issue. So let's try it out once again, but this time I'm gonna like push a change to our prompt, for instance, and see if the pipeline is working. But I think the only reason why this build was failing is because those commands or the SAM deploy command was running at the same time. So it created some kind of context switch between the two commands with the CloudFormation stack, since it's the same stack we use for the deployments. So what I'm gonna do is update the prompt. So for instance, I want like a weightlifting workout plan with barbell only. Sorry, I had a typo here, and I don't want like no cardio exercises because I'm not a big fan of cardio exercises. So for that, I'm gonna push those changes. Now, if I push this to master, if I update this one, as you can see, we have now our pipeline, and it will like run the different steps we have defined on this file, and then it will deploy this new Lambda function entry points to our AWS Lambda function that we have created. So let's give it a few seconds to be completed. And by the way, like those changes that I'm doing today are done automatically on the latest version of the Lambda function, but on a production environments, you should like leverage versions and aliases. That way you can separate the different runtime environments, which you can do, of course, with SAM. But for this example, just like pushing everything to the latest version of the Lambda function. So now it's running the SAM deploy command. So again, it will update our stack and especially the Lambda function so that it includes the latest changes. So let's give it a few seconds to be completed, and then we can test out if those new changes has been deployed to our Lambda function. So as you can see, the stack has been successful and our build has passed. So now every time we update or fine-tune our prompt, our Lambda function will be updated automatically through the GitHub Actions and of course SAM. So let me refresh this again, and I will try if the Lambda function is still working properly. So again, I will use this empty payload, and the workout plan will be generated, and I should receive the workout plan here, as you can see. So that's how we built a Lambda workout generator from scratch. So we have covered how to schedule a cron job to trigger this Lambda function on a specific schedule. We have also covered how to integrate with ChatGPT to generate our workout plan, and also how to integrate with Twilio to send a WhatsApp message. And we have automated the overall process with SAM and GitHub Actions. So looking forward to see your examples on how we are going to improve this application. Again, there are a lot of things that could be improved, especially with the prompts, so that you can, for instance, build your weekly plan and also take into consideration like the max PR that you have, so that not only will send you like how many time you need to spend on each exercise, it can also send you like the volume, or for instance the weight that you need to lift for each exercise. So of course this is something you can include on your prompts, but I think now you have a clear idea about how you can build this workout generator so that it will be your next AI trainer coach. So that's all on my side. As I said, the source code will be available on the GitHub repository in addition to the video, so that you can watch this again. And again, if you have any questions, feel free to drop it on the chat. And for those that are watching us on the YouTube video afterward, you can join our Discord or send us a DM on LinkedIn or Twitter. We'll be more than happy to see what you are going to build with this demo. That's all on my side. Thanks a lot.
Thanks a million, Mohammed. That's absolutely incredible, the amount of information that you've been able to jam pack in record time, putting so many different pieces together. It was really, really cool. I just have a few things here, so if anyone has any question, please feel free to write in the chat, and we'll get to it. Yeah, like, it's incredible the amount of different pieces that you've been able to put together, and just how that quote space, the prompt space for the ChatGPT function can kind of like spark so many different ideas of so many different apps that we can build. And that leads us to the challenge that we wanted to share with everybody here now, is that if this particular workshop prompted or kind of sparked any ideas for your side project, and maybe you would like to try out connecting ChatGPT to something and creating your own serverless app, we're going to give you a month. On the 28th of next month, so on the 28th of April, we'll have a look and we'll see all of the different projects that have been submitted. So this is the challenge. If you want, and if you have any side projects that this inspired, share them, right? Work on them and share them, and then tag Tailwarden, and also add the hashtag Warden's Assembly Challenge. And at the end of the month, we're going to choose the three best projects that have been submitted, and we'll share GitHub sponsorships to those three winners. If also possible, we'll also send some swag and possibly feature your work on the Tailwarden blog, potentially even a video of us reviewing your work. So if you feel like this has sparked anything and you'd like to work on something like that, feel free, and we'd love to showcase the work that comes from that afterwards. Again, just to echo that, all of the source code is going to be on the GitHub server, on the GitHub repository inside the Tailwarden organization. And I also shared the 5-question survey there. If you have some time, feel free, and it'd be really cool to know what you would like us to share in future workshops. This is something that we want to do on a regular basis, to be able to give back and create value for the community here, because first of all, you help us a lot with ideas and with feature requests, and with contributions to help grow and make Commissar a better tool. But having that being the case, we'd love to share back with you with these kind of sessions, and just see what we can evolve into as a community. So I think that's pretty much it for us for today, for the first Warden's Assembly. Thanks a million to everybody who joined us live here, and yeah, I'll edit this and upload it to YouTube shortly. Thanks a million, and catch you next time.